Hello and welcome to lesson 7. Today's lesson is on electrical power. So have a look at these three pictures and think to yourself, which of these transfers energy the fastest? Probably you'd have picked the car, is it transferring energy the fastest, and then probably the motor and then the light bulb. You should remember from year 7, 8 and 9 that this means that the car is the most powerful, because in science power means the rate of transfer of energy, how fast energy is being transferred, and the light bulb is the least powerful. It transfers energy the most slowly. Today we're going to look at electrical energy and electrical power. So we know that power is the rate of transfer of energy. Anytime you see rate, it means divide by time. So if you wanted to write a formula, then power is energy divided by time. And of course, the units of power are watts, unit of energy are joules, and the unit of time is seconds. So what exactly do we need to do to get electrical power? Well, electrical power is given by a different formula. It's given by this formula, which is potential difference times current, or sometimes you might see it voltage times current. So this is general power. This is always true. If you know the energy and the time, you can work out the power of anything, whether it's an electrical item or whether it's something to do with forces. You can work it out. If it's an electrical circuit and you know the voltage and current, you need to use this formula here. The units are the same. This is watts, volts, obviously, and amps. So what do we mean by electrical power? Well, we obviously know that a cell is pushing the electrons, the charges, round a circuit. And as it pushes the charges around a circuit, it does work on the charges because you need to transfer energy for something to move. So the cell is transferring energy. So the rate at which it transfers energy is the cell's power. And as these charges move through something, maybe a bulb, a heater, they are transferring their energy to that object. So the rate they transfer energy to that object is the power of that object. So electrical power, as we've said, is potential difference times current. Power is V times I. Now, we also know that this is true. Potential difference is current times resistance. V equals I times R. So supposing we take this formula here for V and substitute it in this equation here, like this, what do you end up with? You can pause the video now and just quickly write it down. Fairly obviously, power is current times resistance, or current squared times resistance. So this is a second version of electrical power that you also need to know, remember, and be able to use. If you're given voltage or potential difference in current, you use this formula. If you're only given current and resistance, you use this formula here. This is particularly useful if it says what's the power dissipated across a resistor. Dissipated means transferred. Now, I'm just going to show you one other derivation for those of you who wonder why is it V times I? Where does that come from? Right, it's actually really simple to get there. So remember, electrical power is potential difference times current. How do we get there? Well, we know that the definition of potential difference is energy transferred per unit charge. So as a formula, potential difference is energy divided by charge. We also know that current is the rate of flow of charge. So current is charge divided by time. So what happens now if we times these two things together? So V times I is obviously going to be E over Q times Q over T. So what happens? Oh, look, those charges, the Q's cancel and we get energy over time. What is energy over time? Power. So this is why power is V times I. You don't need to remember this slide, but it's quite useful because I've always certainly wondered, why is it V times I? It's not immediately obvious. So one other thing, they will try and trick you a lot in exam questions. They won't always give you watts, they might give you kilowatts, and they might not give you seconds, they might give you minutes. So you always need to be able to convert from watts to kilowatts. So here are a few examples. If they gave you 3.5 kilowatts, you times by 1,000, 3,500 watts. Supposing they gave you 0.02 kilowatts, you times by 1,000, you get 20 watts. If they gave you 0.45 kilowatts, again times by 1,000, 450 watts. So just a few examples there. And then obviously 60 seconds is a minute. So just a few examples there of converting. Okay, they won't tell you to convert, but you just have to remember that if it's electrical power, you need to convert to watts to seconds. So I'm going to just go over 3 quick examples of using P equals I squared R, just to help you out. So here's a typical question. A resistor has resistance 40 ohms and a current of 0.6 amps. Find its power. So what is our power equation? Well, we've got current, we've got resistance, so we need to use this equation here. So we need to put in our numbers, current squared times resistance, and we get our answer in watts. Another example of a question. Bulb has power 55 watts and a current of 0.2 amps. Find its resistance. So again, we've been given power and current. So we need to use this equation here. P is I squared R. Substitute in our numbers. Now this time, we're trying to work out resistance. We've been given power and given current. So if we write this out, then it's really easy to work out the resistance because we know what this is, 0.2 squared. We can type this in our calculator. And then we know that obviously to get this on its own, you have to do 55 divided by this here. Okay, so that's simplifying it, rearranging, solving. And finally, this question, an electric motor operates with power 390 watts, its resistance is 45 ohms. Find the current through the motor. So this time it's asking for current, it's given us power, it's given us resistance. So again, we want P as I squared R. We plug in the numbers that we do know. We're trying to work out the current this time. So firstly, we can divide. Remember that when we divide, we're getting current squared. So how do you undo a squared? Well, you obviously need to do a square root. Square root of 8.67 gives us our answer. So these questions are not hard if you follow this format. If you write out the formula, sometimes you might even write out R equals current equals, etc. Write it out with numbers in and rearrange. If you follow these steps, I promise you, you will get the marks. If you try and skip these steps, you will not do as well. You will make silly mistakes. So there are 2 formulas for electrical power. Power is I times V, or power is I squared times R. You need to know and remember both of these. You can now stop the video and complete the questions in the lesson.